Okay, so I'm going to record some problem solving, and we're still at linear momentum conservation, and let's do a couple of problems, and then we're going to move, maybe a third one, and then we're going to move to impact. So this problem 1540 talks about a boy, and he's 60 pounds, and he's on cart A and jumps on cart B. Both carts A and B have the same weight, 60 pounds. We're shown here how the 12, 5, and 13 orienting the direction of the velocity. And so what are we going to write? Linear momentum conservation, of course. And we know this, again, problem is 1540 with a star in front, and we sum linear momenta. So mv1, sum of mv1 equals sum of mv2. We know that by, or we can multiply with 32.2, so this gets us, we can use instead of mass, weight, the weights. So what do we have? We have initially, and by the way, we're going to analyze the problem in two instances. First, just the boy and the cart and cart A, and then boy and cart B. This time the boy lands on cart B. We're going to assume positive to be to the right. So originally boy is on the cart A and motionless, so we have 0 plus 0, and then equals to weight. I said we're going to use weight, so weight of boy times velocity of boy relative to the ground, and then I have velocity, rather weight of the cart, and which one will be cart A? So let's say A, WA times velocity of A. We want to again find the final velocity of both carts after the motion. Again, the boy lands on B and remains on B, on cart B. Okay, so we have velocity of the boy, and will be in the horizontal direction. So he jumps at an angle, but will be the horizontal direction that there's velocity exchange between A, B, and the boy. So what is velocity of the boy relative to the ground? Is going to be, I said positive to the right, so it'll be negative. It will be the 4 feet per second cosine of the angle there. So and cosine will be 12 over 13, so it will be 4 feet per second times 12 over 13. Right, so this is the velocity with respect to the cart, and then plus velocity of cart A. So the above equation now becomes, and let's move 0 to the right, so I have negative would be 4 times 12, that's 48 over 13, 48 over 13 times weight of the boy plus velocity of A times the weight of the boy, and then plus velocity of A. I flipped, so it's velocity first and weight second, not the other way around. All right, so velocity of A times weight of A equals 0. So we can solve for the velocity of A. That's the unknown. And velocity of A is going to be 48. So this goes to the right. So it'll be 48 over 13 times the weight of boy over weight of boy plus weight of cart A. All right, so 48 over 13 times boy is 60 pounds over 60 plus 80, close parenthesis, equal. So this is 1.582 feet per second. This is the velocity of the cart. Now we want the velocity of the boy relative to the ground, and so we go back here and say negative 48 over 13 plus the calculated 1.582. All right, and this is, so negative 48 over 13 equals, this is negative 2.10989. That's easily 2.11 feet per second. Okay, so here we are. We calculated the first velocity that was required. We need the velocity of the boy relative to the ground, because this is going to be the velocity at which he lands on cart B. He's going to move on a parabola, yes, will slow and then accelerate back down, but we know very well the horizontal component of the velocity in gravitational field stays unchanged, and this is it. Okay, so now we're going to write the, let me see, so we're going to write the angular, rather linear momentum conservation of the boy. So it'll be, and we're going to use again weights. So what do we have initially? We have the velocity of the boy, this one, relative to the ground that we just calculated earlier, times the weight of the boy. Okay, and don't forget this is a negative value. And then we have the weight of the cart B times 0. It's motionless, equals, there will be the weight of the boy plus weight of cart B times their combined velocity. So it'll be B2, let's say. Okay, so we have negative 2.11 times weight of the boy is 60 pounds equals weight of the boy 60 plus 80 times velocity of cart B after the boy lands on the cart. Okay, so velocity of cart 2 after boy lands on it is, so this piece times 60 over parentheses 60 plus 80 close parentheses equals, so we have negative 0.9 0.04 feet per second. And again, negative, it means that is to the left. Velocity of A is to the right. Velocity of the boy relative to the ground is this one. Do we need to calculate the relative? Well, relative velocity between the two carts will be just the sum of, or rather VA minus VB2, so it will be the sum of these two velocities. Okay, so this was problem 1540. Again, recognizing that as the boy jumps from cart A to cart B, he's again moving on a parabola, but the horizontal velocity, it's going to remain unchanged. In the vertical direction, the velocity of the boy, it goes to 0 and then accelerates back to the being at the same level, back to the so magnitude is the same velocity. Now we care only about the horizontal velocity because it's along the horizontal axis that we have velocity. In the y direction would be like 0 equals 0 because there is no velocity. Okay, so let me pause and choose another problem. All right, next problem I'm going to solve is 1543. And what do we have? We have a 20-gram bullet traveling at 400 meters per second and strikes a stationary block. So this is mass of the block is 2 kilograms, and this is mass of the, I use lead, let's say L is 20 grams, or 0.02 kilograms would be 0.02 kilograms. And there's friction between the block and the surface, the horizontal surface, and we want to find the distance traveled. Okay, so what we need to do is to calculate what is the initial right after the bullet gets embedded into the block. What is the velocity of the block and the bullet? Okay, so this would be, let's call it V2. And then this would be the initial velocity of a system consists of block and the bullet. And we write principal linear momentum, so we'll have the is it linear momentum? Yes, will involve time, yes, but we can also find stopping distance using energy conservation. So the work of the friction force is going to be the kinetic energy of the bullet and the block right after the impact. Okay, so first thing first, we need to find the velocity of the two together. So we, again, problem is 1543. And we have the mass of the bullet times the velocity of the bullet. I used L from lead, for lead. So this is L. And mass of the block times velocity of the block, which is 0, equals mass of the bullet and the block times velocity 2. Okay. Again, this is 0 because initial velocity of the block is 0. So I have velocity 2 is velocity of the bullet, or the mass of the bullet, over mass of the bullet plus mass of the block times velocity of the bullet. Okay, so we have 0.02 kilograms over 0.02 plus 2 kilograms times 400, and numbers are 0.02 over 2.02 equals times 400 equals, this is 3.96 meters per second. So this is the velocity of the bullet in the block right after impact. Now we, if we draw a free body diagram, we have the normal force. This will be the mass of the bullet, or the block and mass of the bullet times acceleration to gravity, and this is the friction force. Okay, so here that we have, it says distance travel, determine the distance the block will slide before it stops. And so what do we have? We have kinetic energy of the bullet and the block and the bullet will be V2 squared negative the work of the friction force, and that's going to be N times kinetic coefficient of friction. So friction force is kinetic coefficient of friction times normal force, and normal force is the weight of the two together. So we have the distance traveled, which we want to find, so x times friction force, and so kinetic energy minus the work ends, it goes to 0, x distance to stop. Okay, so distance to a stop is going to be, let me use 0.5 instead of 1 over 2, 0.5 mass of the, that will be 2 plus 0.02 times this 3.96 divided by the friction force. The friction force we said is kinetic coefficient of friction, that's 0.2 times normal force, and that's mass of the 2 plus 0.02 times 9.81 accelerated to gravity. Okay, so again, what I did, I took this group and I'm dividing it by moving negative x times friction force to the right, so this becomes equal sign in a sense. Okay, so equal here, so x equals this group divided by friction force. So below the friction force. Okay, so this goes away. And we have like 0.5, that is 1 over 2 times 3.96. I still have it on my calculator screen, over 0.2 over 9.81. All right, so times 0.5 over 0.2 over 9.81 equals, it's 4.037 meters. Okay, so this was one approach. The other approach is to we can use linear momentum. so we can state that mass of the block plus mass of the bullet times the velocity of the two together initially plus the impulse. The impulse of the friction force will be, so from 0, assuming that we start the clock new, or we start moment 0 is when the bullet finished to get embedded into the block, 0 to t, friction force times dt equals 0. Okay, so, and then having time now, we can, so from here we'll get mass of the block plus mass of the bullet, V2, this is known, and then friction force creates a negative impulse, so it'll be nu k, that is kinetic coefficient of friction times mass block plus mass lead times 9.81 times t equals 0. Okay, so mass goes away. We can calculate time to stop, so it would be V2 over coefficient of friction kinetic time over 9.81, and V2 is 3.96 over 0.2 over 9.81. So 3.92, rather 3.96 over 0.2 over 9.81 equals 2.0183 seconds. Okay, so now that we have the time, we can calculate the distance traveled using, and this is a constant acceleration problem. So we'll need to find the we need to find the distance traveled. So again, we're is it constant acceleration? Yes, it is. It is definitely. Now, this is a lengthier approach. We could find the acceleration as being friction force divided by the. So really a lengthy approach. No need to calculate. Maybe if it asks what's the time to stop, yes. But other than that, we can just say distance traveled is initial velocity times time, and that will be v2 that we just calculate times time that we have, minus 1/2 constant acceleration times t squared. And what is the constant acceleration? It's just going to be friction force divided by mass of the block plus mass of the bullet. Okay, and this is nothing but the coefficient of kinetic friction. Okay, so we can quickly verify. So I have the time put in the memory. It will be times 3.96 negative 0.5, that is 1/2 times 0.2 times time squared equals, it doesn't match. Let's try again. So I have V2 that is 3.96 times 2.0183 minus 0.5 times 0.2 times 2.0183 squared equals so it's I've got a different number. Let me pause and double check. Okay, so the mistake was that, you know, I skipped steps. So we have sum of forces in the horizontal direction is friction force to the left negative, and that's equal to mb plus ml times g equals and times coefficient of kinetic friction mb plus ml times AC. So really here I have kinetic coefficient of friction times g. Okay, so wasn't coefficient of kinetic friction divided by 2, but rather 0.2 times 9.81. All right, and with this we get you can check, we get the same distance, that's about 4 meters. Okay, so this was the other problem, 1543.